Hello everybody. So in this video we're going to continue with chapter 14, Integral Calculus 1, specifically section 14.6, areas. So it's areas between curves of functions in the form y equals f of x. So first we have example 14.26 where they ask us to find the area between the curve f of x equals x cubed minus x plus 1 and the x-axis over the interval -1, comma 2, both included. So what they want us to do is to find this blue area that we can see here under the curve. These cases are pretty straightforward. When the curve is above the x-axis, all we have to do is a simple integration. So in other words, we would need to integrate from -1 to 2 the function x cubed minus x plus 1 dx. And this is a pretty straightforward integration because we know that this is simply going to be the power rule. So we're going to get x to the 4 over 4 minus x squared over 2 plus x, and then the interval from -1 to 2. So it's a simple substitution then, and a subtraction, as you guys very well know. So this is going to be equal to 4 minus 2 plus 2, and all of this minus 1/4 minus 1/2 minus 1. And if we do the math, this is going to give us 21/4. Very well, so next we have example 14.27. And it says, find the area under the curve f of x is equal to x cubed minus x minus 1, and the x-axis over the interval from -1 to 2 included. So again, it's going to be the blue area, as you can see here. Now there's a problem. If you solve this one directly, like we did in the previous case, this area is going to give you a negative because it's under the x-axis. And then this one would be positive, right? But we want the areas in positive terms. We don't want them in negative terms. Therefore, what we have to do is separate these two parts of the curve in two different intervals, right? So one interval would be from -1 to whatever this value here is for x, and then from this value of x to 2. That would be the other integration we would need to do. That means that we would have to solve the equation x cubed minus x minus 1 is equal to 0, but this one is too difficult to solve because it's not going to give us whole numbers. It's going to give us probably a root or something with many decimals. So this is a case where we would use the calculator. Since we want the area in positive terms, there will be occasions where you will have to leave this in negative terms, but that's more for problems of physics when you want to find, for example, displacement. But in this case, they want the area in positive terms. So that means is that in reality, we have to find the integral from -1 to 2 of the absolute value of x cubed minus x minus 1 dx. And this is something that we will plug into the GDC. Okay, so here we are with the graphing display calculator. And for integrals, we need to use the math function here. And then option number 9, which is finite integration. So we click on number 9, and it takes us to this screen. So we said the interval is from -1 to 2. So remember that we have to type negative with this symbol here, -1 to 2. And then in order to get the right answer, we need the absolute value. And the absolute value you're going to find also by clicking on math, and then you move one to the right, and it's going to be the first option there that says as absolute value. So 1, and there we have the absolute value symbol. So now we just have to put in the function, which was x cubed minus x minus 1. And then we also have to put the symbol for x here to indicate that we're going to do the integration for x. And just click on enter, and there it is. So next we have example 14.28, and it says find the area enclosed by the graph of the function f of x equals x cubed minus 4x squared plus x plus 6 and the x-axis. So this is similar to the previous case where we would have a positive area here and the negative area in this part. But since we're not doing a physics problem of displacement or anything similar to that, we want to find the areas in positive terms. So in other words, we need to find the integral from, in this case, we can see that it starts at -1 to 3. And it's going to be the absolute value of f of x. But we can also rewrite this as the integration from -1 to 2 of f of x, right? Because this part is positive, plus the integration from 2 to 3 of minus f of x. What we're doing is simply applying the rule for absolute value, right? Oh, and let's not forget, always write this, right? Dx. Okay, so let's do this. And then, so we say from -1 to 2, the integration of straightforwardly x cubed minus 4x squared plus x plus 6. And then here we could just rewrite this as plus the integration from 2 to 3 of, and we have to switch all the signs, right? So this would be minus x cubed plus 4x squared minus x minus 6 dx. Okay, so this will be equal to, if you notice, this is the same as saying x to the 4 over 4. So we would do x to the 4 over 4 minus 4x cubed over 3 plus x squared over 2 plus 6x from the interval between -1 and 2. And then this plus x to the 4 over 4. Well, this will be negative x to the 4 over 4 plus 4x to the 3 over 3 minus x squared over 2 minus 6x. And this one from 2 to 3. So this is a 2 here. Okay, and then this is going to give us 45/4 plus 7/12 if you do all the math, which is equal to 71/6. So next we have the topic of area between curves. So let's look at example 14.29, and they want us to find the area of the region between the curves y equals x cubed and y equals x squared minus x on the interval 0, 1. So the rule for these areas is that if the top function, let's say it's f of x, and the bottom function here is g of x, then the rule says do the integration, right, from a to b, if that's the interval, of the larger function, or the one that's on top, f of x, minus the bottom one, which is g of x, and of course dx. So this is the general rule for finding the area between curves. Top curve minus bottom curve. So in this case, f of x is always the top curve and g of x is always the bottom curve. So it's a pretty simple, straightforward integration. And then we would say, well, the area is equal to the integral between 0 and 1 of f of x, which in this case is going to be the top function here. And let's see which one is which here. So the top function is x cubed. So this is x cubed, obviously the one that looks like an S. And this one, the blue one, is a parabola. So that means it's going to be x cubed minus x squared minus x dx. And then this is just another straightforward integration. So we're going to get x to the 4 over 4 minus x cubed over 3 plus x squared over 2. And then from 0 to 1, and if you do that, it's going to give you 5 over 12. Very well, so next we have example 14.30, and it says find the area of the region bounded by the curves y equals x cubed plus 2x squared and y equals x squared plus 2x. So remember that in these problems with finding the areas between two curves, we have to do the integration of the top curve minus the bottom curve. So notice that there is something interesting going on here. Notice that this is the cubic one, right? So let's call the cubic one y1, and let's call the quadratic one y2. So notice that this is y1. So y1 is on top. This is y1 here, above y2. But after they intersect at this point, which I assume is 0, but we have to verify it, the curve y2, or the quadratic curve, is on top of the cubic curve. So we have to take that into consideration when we find this area. So first of all, let's verify where these two curves intersect. And that's easily found by equaling the curves and solving for x, right? So this would be x cubed plus 2x squared is equal to x squared plus 2x. And then from here, we're simply going to obtain x cubed plus x squared minus 2x, equal it to 0 and solve. And we're going to get x times x squared plus x minus 2 equals 0. And then we can just factor this out. And we're going to get x times x plus 2 times x minus 1. So notice that the solutions to this would be, and let's do them in order, -2, 0, and 1. And we can see that clearly here in the graph. So the first integration, in order to find the area, which is what we want to do, we should integrate from -2 to 0, top curve minus bottom curve. So we said that the top curve in this case, in this interval from -2 to 0, is going to be, this looks like a 6, 0, okay, is going to be, and let's use a square parenthesis here just for clarity. It's going to be x cubed plus 2x squared minus x squared plus 2x dx. But we said that from 0 to 1, which is the other interval, the situation switches around. So we have the quadratic over the cubic curve. So then we would have to say x squared plus 2x minus x cubed plus 2x squared dx. And then everything else is going to be pretty straightforward because all we have to do really is simplify this and do the math, right? So let's just do one more step here. So notice that this would be then the integral from -2 to 0 of x cubed plus x squared minus 2x. And then plus the integral from 0 to 1 of, let's see if we can put this in order here. Let's see, this would be minus x cubed minus x squared plus 2x. So if you look at this, notice that if this were a function, and notice that it is exactly the opposite of this one. In sign, notice that the signs are exactly the opposite. So we could actually have that in general. You could find this total area by simply going from A to B and doing the absolute value of f of x minus g of x. And that would give us the area as well. If you had to do it in the GDC or if you want to do it that way, it's perfectly valid. Okay, so what's going to be the solution to this? So this is going to equal x to the 4, the same old thing, x to the 4 over 4 plus x cubed over 3. And then here we're going to get minus x squared. And this is from -2 to 0. And this plus minus x to the 4 over 4 minus x cubed over 3 plus x squared, and this from 0 to 1. And if you do the math, you should get 37 over 12. So in the next slide, you're going to find an example of how to find areas along the y-axis. So here it talks about a case where you have to find the area that is enclosed by the curves y equals 1 minus x and y squared equals x plus 1. Now, because this y is squared, it's probably easier to rearrange these and put them in terms of y, or x in terms of y. So notice that we could rewrite this as x is equal to 1 minus y, which would be this red line here. X equals 1 minus y. It was already indicated here. And then if we rearrange the other curve, it's obviously going to be that x is equal to y squared minus 1. So that's this inverse parabola here. This is the curve, x equals y squared minus 1. So then we would proceed in the same way, but we would do the integration in terms of y. And here what you do is that you subtract the left-hand side curve from the right-hand side curve. So notice that you can see here the integration from -2 to 1. And because it's in terms of y, right? So that's what you have to be careful with. So it's from -2 to 1 of the right-hand side curve, 1 minus y, minus the left-hand side curve. And don't forget to do the absolute value of that, absolute value, dy. Okay, so in this case, you would get 9/2. But the procedure is just the same. The only thing you have to be careful with is remembering that the interval is in terms of y, and then it's subtracting the right-hand side curve minus the left-hand side curve.